Good morning, everyone. So, very good morning, all. I guess probably means many people are still about to join. Thank you all for joining bit early. So, we will start straight away the session. Welcome to AskSelva 007 on Power System Studies. Probably last couple of weeks we are continuing this session without any interruption, and I guess this will go on. Means what say without any disturbance on every Sunday 10 a.m. Right, so once again I welcome you all for this AskSelva session. I guess my screen is very clear and means I am loud, right? If I am loud and clear, can you just give me a means what say confirmation in the chat box so that I can move forward? So this is what we are going to see today. How much percentage of transformer winding is protected for various faults by overcurrent protections? Last week we have posted this question. Sreekant has answered that. So from there we are going to means what say take it forward from his answers. What are the means what say additional questions? How to look at this? Means how to look at phase faults, how to look at the ground faults, how to look at the fault on the delta winding, how to look at the fault on the star winding. So we have quite a lot to discuss on that perspective. Thank you, Muthuvel, for giving a confirmation that it's clear. Thank you so much. So that's what we are going to discuss. But I guess probably this discussion goes on. It may not be probably an end today because there needs quite a lot of depth of understanding which is needed. But at least means we'll say he has given an answer in a 5 page. He has given some some references as well. So we will means go depth on that to extent possible today, and but that question will continue for the upcoming weeks as well. Why arc flash protection has to be considered only for an incomers and not for outgoing feeders? That's a question from Charinath. I could see that he's already here. So we will definitely answer that questions. But if anyone has the answer for that question, please post the answer for that question of what's Charinath question. Why arc flash protection has to be considered only for an incomers and not for outgoing feeders? Right. And again, next question is also from Charinath. Motor protection relay curve between hot and cold withstand capability curve or means below both hot and cold withstand. Then that's an again next question from Charinath that we are going to address. And we have already started this fourth question, and I thought of coming with some simulation for a better understanding because there are quite a lot of questions also after AskSelva in the comment boxes like what's the significance of maximum and minimum fault current in relay coordination, when to use maximum short circuit current, when to use minimum short circuit current, is it right, why standards are calling that minimum short circuit current is needed for relay coordination, but Selva is telling that you need to coordinate for the maximum short circuit, etc. Right, we will probably means I have some simulations and we will touch upon this is what we are going to see today, and few updates. This I have given the last week also. If you have missed the last week's session, this is the updates. We are starting a subject matter experts interviews Q&A session starts from 3rd January. That's next year. That probably means what to say. We have only one more session. Today is 19th. So today is 20th. 27th we have another session that is exclusively by me like AskSelva. And after that, what we are going to do from 3rd January, along with me, some expert members will also join to answer your questions, or probably that could be like a discussions or other things. And we are planning means on live sessions with the participants either in MS Teams or in Microsoft Zoom. That start from 1st January 2021. The active participants, those who are means what say willing, those who are actively participating here will be picked up, and means what say they will be means what say joining every Friday evening, that is a 6 to 8, every Friday evening 6 to 8, where we will be discussing some advanced topics, but that's for a closed group. That's not an open in YouTube channel. That's in Microsoft Teams or Google Meet or Microsoft means Zoom. So that's closed group. And sector specific Q&A is also we are going to explore. That's from 3rd January. That probably point number 1 and 3 is almost means similar. And stay tuned for this. And if you have any questions, please feel free to post your questions either in the chat box or in the dedicated Google form link which has been shared in our office website and my personal LinkedIn also, and official LinkedIn page also it has been shared, that you will be able to find out in the description of the previous AskSelva questions also. You just means what say please post your questions also so that questions are not really missed out. Yes, Kanagraj, I'll take up your question. Thank you. Yep. So before going to Q&A, let's have some questions. So probably this I thought of means introducing from last week. Last week I have asked some probably means or say questions which needs to be elaborated. This week I have framed a question in such a way that it's an objective, you can answer it. So I have means or say I guess 3 or 4 objective questions. This is the first question. So if you have the answer for this question, type out one and give the answer, like one in bracket A or B or C or D, whatever the right answers. So let me give a few seconds pause so that means I can get few answers in the chat box, and then let me move forward. So first question is, real power will flow from higher voltage to lower voltage. Option B, higher angle to lower angle. Option C, lower voltage to higher voltage. Option D, lower angle to higher angle. So if you know the answer, just type out the answer with the question number 1, because there are upcoming questions as well. Question number 1, in bracket you answer it like A or B or C or D. If I get, yeah, thank you Kanagraj, thank you Kanagraj. Okay, so the way Kanagraj is answering, that's an ideal way of answering, like means you need a question as well as also you have to put the answers. So anybody else, if you want to answer that, please answer this question. Real power will flow from, yep, right. Yep, yeah, thank you for putting the answers. All right. Question number 2. So I request you to put question number and the answer, right? And the option, right option. You need not really type out the full answer, like how Kanagaraj or Sunil or Swati is answering. So probably the same way you can put up the answer. Question number 2. Reactive power will flow from higher voltage to lower voltage, higher angle to lower angle, lower voltage to higher voltage, lower angle to higher angle. That is question number 2. I am expecting question for means for say second question as well now. So means when you are answering the question 2, probably means for say type out. Yeah, thank you. I could see there are some questions which are coming up. Thank you for that. All right, good. I will give you the answer as well, don't worry. This is the third and I guess last question. Reactive power injected by the capacitor, reactive power injected by the capacitor is proportional to the applied voltage, is inversely proportional to applied voltage, is proportional to square of the voltage, it's inversely proportional to square of the applied voltage. That's the question. The third question, if I get some answers and I could quickly give the answers for all these 3 questions, then we can move forward to all the other questions which what we are going to see. Yes, I guess third question also answer comes up, that means you got the answer. Yes, all right. So I guess third question is also visible, which you can answer it. So let me try to answer all the questions one by one. Right. Real power will flow from higher angle to lower angle. Real power will always flow from higher angle to lower angle. So you might be aware of this formula like P equal to EV by X into sine delta. So delta is del 1 minus del 2. If you have a sending in bus and if you have a receiving in bus, and assume that sending in bus angle is del 1 and receiving in bus angle is del 2. When del 1 is greater than del 2, means power will flow from sending in bus to receiving in, that is bus 1 to bus 2. So real power always flow from higher angle to lower angle, which can be related with the formula P equal to EV by X into sine delta. If you're not aware of that, you just Google it, you will find out. Or probably you can put up some small quick simulation and you can plot the results with an angle. Then you will be able to easily get, where the real power is flowing. If the real power is flow always from higher angle to lower angle, and if you connect some loads, then automatically the angle of that bus will be reduced so that the power can reach out that load, right? So question number 1, the right answer is higher angle to lower angle. That's the answer. 1, the right answer is means B. And thank you all for probably many of you have given the right answers, right? Start from Kanakaraj, Sadanand, Sunil, Swati, right? Yep. So Charinath, Ilango. So thank you for all your answers, right? So that's the right answer. Option 1, real power will flow from higher angle to lower angle. You can simulate, but for a better understanding, you can simulate. But I am not really going to simulate today. I have some other simulations. So if needed, we can simulate the same thing in the next week. Second question, means reactive power will flow from. This is another tricky question. Reactive power will flow from higher voltage to lower voltage. Reactive power will flow from higher voltage to lower voltage. That means if there is a 400 kV system, sending in bus voltage is say example 410 kV and receiving in bus voltage is say example 395 kV, then the reactive power will flow from the bus which is at 410 kV to the bus at 395 kV. So reactive power always flow from higher voltage to the lower voltage predominantly, right? So the answer for the second question is A. The question number 2, the answer is A. And I guess Sadanand, Sunil, Charinath, Muthuvel, Ganesh, Ilango, means many people have answered that question right. So reactive power will always flow from higher voltage to lower voltage, and probably means you need to also understand if you want to increase the bus voltage you have to inject a reactive power, and if you want to reduce the bus voltage you need to consume or draw the reactive power from the bus, right? That's the question, and probably I request you to simulate on your own to validate and all this stuff, so that helps you to means make better understanding. So if not, probably means I will come back next week with the simulations for this examples, right? Third question, reactive power injected by the capacitor is proportional to square of the applied voltage. Q, reactive power Q is V square into B suffix C, or V square divided by XC. So reactive power supplied by the capacitor is proportional to square of the voltage. So whenever there is a reduction in voltage, the reactive power generation of the capacitor reduce proportional to square of the voltage. That means if there is a 10% reduction in voltage, the reactive power generated by the capacitor will come down by 19%. Let me repeat that point. Reactive power injected by the capacitor is proportional to square of the applied voltage. That means answer is 3C. That's the answer. I guess many of you has given the right answers. Thanks for that. And uh, the next point which I have added, like if there is any 10% reduction in voltage, say example if the voltage is coming down from 100% to 90%, there is a 10% reduction in voltage, that will reduce the reactive power generation by 19%. That means the voltage came down from 1 per unit to 0.9 per unit. So the reactive power Q is proportional to V square, so that is 0.9 square, so you will get 0.81. That is a 19% reduction in the reactive power, 19% reduction in the reactive power generation of the capacitor. I guess as of now everything is clear. If it is all right, probably means put clear in the chat box. And thank you all. I guess we know Charinath, Kanakaraj, many people have given the right answers. Thank you so much, and I'm moving forward. If everything is clear, please give clear in the chat box so that I can move forward. Yeah, only one interesting information which I need to update. We are coming up with an advanced industrial power system analysis course that starts on 27th January, aiming probably people those who are already working in industries, right? And they have done some basics of power system analysis. This is not for the beginners. This is an advanced industrial power system analysis, and this starts on 27th, and 27th to 31st, that is Sunday 27th to Thursday 31st, so totally 5 days. The session is like means 10 to 12:30 and 2 to 4:30 or 2 to 5:30. It depends upon the Q&A. 2 to 4:30 is the session, then probably 4:30 to 5:30 or 6 is Q&A. That's for a 5 full days, and means it's not free, it's a paid course. So if you are an industry person and if you have already done some basic studies and if you want to learn some advanced studies, probably means what say you can register for this course. This could be your good year in learning. What we are going to cover as a part of this post you might have already seen in our LinkedIn, and if you not what you have seen in means what we are going to cover there, and means this is what we are going to cover: advanced industrial power system analysis. This is 27th December to 31st December, 10 a.m. to 5 p.m. That is 4:30 up to 4:30 we will have a sessions, and after 4:30 means it's a Q&A. It could be 30 minutes or 1 hour, whatever it is. Then we have a hand holding session for 2 hours every month. That is the first Friday of every month, 6 p.m. to 8 p.m. That's we are going to have. So that means the course will not be over by 31st December. This course will finish on December 2021. That means every month we have a 2 hours follow up with the guys, and probably means that hand holding session, like we will try to address whatever the clarifications questions which they have, or what are the new learnings and what are the struggles which they have. And this is what we have. I mean, we have 5 topics like what you have seen in the poster: load flow, short circuit, relay coordination, arc plus, and harmonics. Probably this is not for a beginners, this is an advanced level. Like this going to talk about drawbacks of slack bus concept. Means everyone is we are using a slack bus concept for a load flow. So where this slack bus concept is not applicable, In that case means whether to go for a distributed slack bus or whether to go for a system controllers. Probably means in an isolated system it is recommended to go for a system controllers, and probably for a large interconnected systems it is advisable to go for a distributed slack bus. So means how we are going for and what are the softwares which supports, and need for secondary controller modeling in a load flow. Probably means for say if you take ETAP it goes only by a swing bus concept or a slack bus concept. So means why do we need a secondary controllers, especially in an isolated systems multiple diesel generators are running? What's the advantage of it? How to control the power flow? Means if how to share the loads, means when two generators are running or three generators are running in a load flow, both real power sharing, reactive power sharing, and probably means maintaining a power factor or a voltage at the point of coupling for a large scale solar plants. All these things which we are going to do. Modeling of power plant controllers for a PV and wind farms for load flow studies. And what's the errors which can cause in a nominal pi transmission line model? Correct, we are modeling the transmission line as a nominal pi model. Is it right? Means this is with some assumptions. What could be the error and what could be the result of this error? And probably means nowadays you can understand like solar is growing, so we generally used to do the load flow analysis only for a maximum load, minimum load and average demand. Is this alone sufficient when the renewable penetration is heavy and probably it's varying from season to season? Load is also changing probably for a large scale systems. So why do we need a quasi dynamic analysis? That is probably means you give a load pattern, you give a solar pattern or wind pattern, and means what's analyzing the system just not for one case, for a multiple case. I mean, so say how to handle the errors if there is any error in the solving it, how to optimize the system parameters, need of unbalanced load flow, means where do we need unbalanced load flow, why our load flow fails in a distribution systems, all this which we are going to talk. We are also going to talk about with the load flow analysis with an energy storage systems, transmission planning, power evacuation studies for large scale power plants. These are all the things which we are going to do. This involves case studies like power factor correction, reactive power compensation studies with solar wind farms, power factor correction, reactive power compensations for traction applications. These are all the real-time case studies what we have done that we are going to explain. And selection of on-load tap changer for three-winding transformers, as well as selection of the transformer impedance for such a three-winding transformers for combined cycle plants. Load flow analysis for a standalone microgrid, load flow analysis for a countrywide network. Means what say this are all the things which we are going to cover. Anyway, this we will be posting it. We will not. I will not go one by one to all this. So similarly, we cover for a load flow, short circuit, not motor starting, load flow, short circuit, relay coordination, arc flash, and harmonic analysis. So what is the image which I have shown in the Word file that will go to the LinkedIn page by tomorrow for us in our LinkedIn page, which you can watch. Load flow, short circuit, relay coordination, arc flash, harmonic analysis. These are the contents which we are going to do. And the registration link is here, and probably means for say the registration link is there at the bottom of this also. And the registration link which I already there in our LinkedIn page. And at the beginning we thought of going only with the 25 participants. Now we have decided to go with means 50 participants based on the interest. So means what to say, if you are willing to register, yes, you can register, and we are sure that means what say there will not be any more than 50 participants on this. And probably means what say when we are taking up this session with a handhold session like 2-hour follow-up sessions, this we will be splitting 10 per batch, and we will be doing it at appropriate time. So that means what say that could be like reviewing what they have done. All right, so that's about that means what's the program which is coming in. So let's move on to this. And probably means if the link what I have said, if you are able to get it, please tell you are able to get it. Yes, Muthuvel Ganesh, secondary control modeling is not possible in ETAP. You're right. So means what to say. That's the reason why probably means what to say that in advanced industrial power system analysis is just not going to talk about ETAP. So we are focusing on the power system simulation than the softwares. Like we will try to use means ETAP, Excel, Power Factory, and other power system simulation softwares which are really relevant to sort out what's the problem which is being means made, right? I guess Muthuvel Ganesh that's perfectly clear for you now, right? So means what say ETAP may not be a suitable software for all the scenarios. So means what is the class advanced industrial power system analysis which we are going to talk about? That's going to talk about with respect to all permutation and combinations, and means what's the software which you need to select and why selection of the right software is important. That also will be covered as a part of that session. That covers like load flow, short circuit, relay coordination, arc flash, and harmonics. This is what we cover, and everywhere we cover with a real-time industrial case studies, right? All right, so let's go on. I guess everything is clear as of now. Let me go on. How much percentage of transformer winding is protected for various faults by overcurrent protection? This is a question which we have posted, and if you remember, if you go back to this last week class, I have asked this question with respect to many cases, like if the transformer is delta star grounded and star grounded, that's the question which I have asked. And when the fault is on the HV winding and when the fault is on the LV winding, I have asked. I have also asked another question when the LV winding is star grounded but it is a solidly earth, if it is a resistance earth. These are the questions which I have asked. That means at least there is a 6 questions which I have asked. And probably means what's a Sreekant, one of our participants, has put up a beautiful report and he has shared the report as a means this you can also do, means whenever we are posting a question, if you know the answer you can do that answer in the same AskSelva link. You can upload. We have given the also the option of uploading this. This is what we had done, and I guess means what say he has just scanned it using mobile, I guess, so may not be properly visible, but he has done a beautiful job. Thank you Sreekant for paying this much attention, right? How much percentage of HV winding is unprotected in a transformer? Differential protection for 11 bar 33 kV 40 MVA delta star transformer. Assume ID min is 0.2 per unit. So means this could be applicable for a differential protection. This could be applicable for a restricted earth fault protection. This could be applicable for an overcurrent protection, earth fault, all these things, right? So we go probably as I that's the reason I told like this question will be keep going probably for at least I mean few weeks of the upcoming our sessions. We will try to understand slowly so that parallel you can also work out. It is assumed that I mean star side is solidly grounded. That's his assumption which he is taking. So fine, whatever it is. Let's take about 110 per 33 kV 40 MVA transformer with a 10% impedance. Full load current he has find out HV side and LV side. So he has selected the CT ratio based on that. That's all right. Faults at delta winding. So if he is look at means what's a fault at delta winding, that's a HV winding he is taking for the case 1. If that case 1 is HV winding and is delta, if there is a phase 2 fault, there is a substantial fault current limited only by the source impedance and the transformer leakage impedance. Therefore, I mean, for say 100% of HV winding is protected in this case. That's he is talking about differential. That's true. I guess last week also I have given the same answer. If the winding is delta and if it is a phase to phase fault, means it is completely protected. No doubt about that. Means there is a delta star transformer 110 per 33 kV 40 MVA transformer. 110 kV is solidly at the systems, and there is a phase fault, that is a phase to phase fault or 3-phase fault in 110 kV delta side, and 100% winding is protected by differential. Let's go to the phase to earth fault. So he has given some answers like the earth fault current is equal to or less than the rated current for the midpoint fault in delta winding. Answer is no. Probably means you need to really look at means what say if there is a delta winding of the transformers and if there is a line to ground fault in the winding of the transformer, means what say it will be looks like a line double line to ground fault. It looks like a double line to ground fault in terms of reality, right? So means what to say all the line to ground faults also will be protected. That means any phase to earth fault also 100% covered on the HV side if the HV side is delta. If HV side is delta, all the single line to ground fault currents are protected by the transformer differential protection if 110 kV system is solidly earthed systems. If 110 kV is solidly earthed systems, then there will be a huge fault current even for line to ground fault current irrespective of the location of the fault in the HV winding, and that is protected, right? If the faults are on the secondary side, then probably means if assume 10% impedance 10 times of full load current, that's what he is assuming. So if it is a phase to phase fault, I means he has worked out some currents and probably means Z1 Z2 Z0 he has assumed something and he is coming up. But beautiful answer. I appreciate the great effort Sreekant for whatever you have done. So but means what's a small corrections which are needed, that is like means first we need to look at means what say I think you have referred this this are all general theory. Probably means if you want we will put up this in our LinkedIn page itself, right? This is a point which he has referred from ABB relay manual AG003 5005. This can be referred in any I mean standard textbooks like power system protection, any power system standard protection book which you refer. Probably means what say they will talk about the same thing. But please we need to make a note like this is given only exclusively for the single line to ground fault if the fault is occurring at the low voltage side for a solidly grounded systems and the resistance grounded systems. Okay, that's what probably we need to understand. So So first we will talk about this. So that means this is not really talking about line to line fault, or this is not really talking about line to line to line fault. That is three phase fault or double line fault or line to ground fault is not talked here. This is talking only the single line to ground fault in a delta star grounded transformer. Means figure 2 talks about when the transformer is solidly at the systems. And please be remember, this will not be applicable again for a star grounded. It is only for a delta star grounded. So here they are plotting like means what say primary current and means what say secondary current, right? That's what they are plotting, and they are plotting the x-axis. You can understand this is the distance of the fault from the neutral. Distance of the fault from the neutral. So means what say if there is a fault at the neutral, the fault current is 0. That's understood. And probably means if the fault is moving away from this neutral point, means the voltage developed across this winding will increase. The system is solidly at the systems. How the fault current behaves is this graph. So here you can understand, even for means if the fault is solidly at the systems, you can understand means was the differential relay operates based on the differential current between these two. So how much percentage differential which you are giving, so that you can easily understand. And if you look at the percentage differential current between primary and secondary, which you can work out, and delta star, that compensation also you need to think of. I guess probably those who have worked in this differential protection might be aware, like means if the winding configuration is delta star, the zero sequence current will not be reflected, how it is to be treated, all the stuffs which you need to means really look at from the stability perspective of the transformer for an external fault and internal fault. Yes, or after all this, probably you can understand means what's at 100 percentage of the length. That means if the terminal of the transformer of the LV side, if there is a fault, the fault current is 10 per unit. That means they are also assuming this probably I by IN, that is 10 per unit. So that means they have also taken 10 percentage as an impedance, right? 10 percentage is an impedance, and that's not really reflected as 10 per unit on the HV side. Is there any answers why it is not really reflected as means what say 10 per unit on the HV side? Is there any answers? You can see, I mean, so say the fault on the LV side, I means what say assuming 10 percentage impedance. So assuming positive sequence equal to negative sequence equal to 0 sequence, and means what say they have given means what say 10 per unit as the fault current. That's a secondary current, but primary current is not really means what to say 10 per unit. It's not really 10 per unit. You can understand. So it is slightly less than 6. How they have arrived that number, and can anyone give the answer in the chat box, like why it is not 10 per unit and why this is this much per unit, and any answers on this? I'm not really going to answer that question today, but anybody wants to answer that question in the chat box? I guess I can wait maybe for a few seconds. Okay, but question is clear. Why the current on the secondary is 10 per unit? Why the primary current, that's a HV side, the current is not really 10 per unit? Why it is less? And why it is less, means what say slightly less than 6? Why this magnitude? Why specifically this magnitude? If anybody wants to give the answer, probably you can use the chat box, or I mean what say the same AskSelva, you can give the answer later also in the Google form. Transformer ratio is not going to play any role, Muthuvel. Simple fact, because means what say we are talking about only in per unit. We are not really talking about the actual current. That I think both for Sreekant as well as Muthuvel Ganesh. All right. So let's go for another question. Like means what say this is the resistance at the system. This is the resistance at the system, right? Again, here we are talking about, you can easily understand the difference. Here means what say though it is not explicitly given. Thank you, Kumaran, perfect answer. But if you put means how you got that answer, that might be great, right? That could be the right answer. Yeah, Kumaran, thanks you for putting right answer, but I want to know how you have arrived that answer. That's the question. So Kumaran, what he has given, that's the answer. Like this value is 10 divided by root 3. It's not really because of transformer ratio. No. Transformer ratio is like means in our case, like we have taken 110 bar 11 kV, it is 10 times. That's Muthuvel Ganesh. All right. So let me come here. So here it is a star grounded means, but through a resistor, that NGR, and here it is not explicitly given in any of the documents, but it is understood that NGR rating which we are putting to limit the current to the full load current. Right? If you are full load current of like 40 MVA transformer 11 kV, what's the full load current which you are working out? So that's the current which you need to, I mean, what say you are limiting to. Generally means what say NGR will be used to limit the current to like 300 amps or 400 amps or 800 amps, depends. But we need to understand, means here in this example what they have given, they have used resistance at the system to limit the fault current to the rated current of the secondary or rated current of the LV. That's what the assumption which has made in this drawing, right? Having said that, so this will become automatically 1 per unit. This becomes automatically 1 per unit, right? That's the secondary current. But here the primary current also you can look at that, that's also means what's say reflected as means what's say 1 per unit on the HV side as well. So why, means there why it is root 3 times, but why not here root 3? So that's another question, I am leaving it to you. But I can say only one important aspect won't we miss, especially when we are going for such a kind of solid earth system to a resistance earth system, is an important to make a note with respect to the simulation also. Like means what say we tend to keep the X by R ratio same for both solidly earthed systems and resistance earthed systems for both three phase and single line to ground fault. Answer, that's not right. So let me probably quickly go to the simulation to highlight means what's the mistake we generally do. Like means what to see, I mean model some systems. I have just put up 11 kV. 11 kV I have modeled as a grid just to take up other three questions as well. All right. So here I mean what to say, I have taken the fault current, three phase fault current as 37.2 kiloamps and single line to ground fault current as 3.2 kiloamps. Means three phase fault current, you can understand three phase fault current is 37.2 kiloamps and single line to ground fault current or single phase fault current is 3.2 kiloamps. By means of this, can you just define what kind of earthing system which is adopted for this 11 kV system? If the three phase fault current is given as 37.2 and single phase to ground fault is given as 3.2 by customer, means if you are asking three phase fault current, single line to ground fault current and X by R ratio for both three phase and single line to ground fault. But means what say he has told, means what say three phase fault current is 37.2, single phase to ground fault current is 3.2 and X by R he has given only a common X by R. So from that means what say my question is like, by means of looking at this alone, three phase fault current and single line to ground fault current, is it possible to say what kind of earthing which we have adopted for this? Any answers for what kind of earthing which we have adopted for this? So then probably means what say, let me add up this with respect to the maximum fault current and minimum fault current simulation also. There are two ways of simulating this. One probably means people connect two different grids and they will create a scenario with respect to the configuration manager. That means for a maximum fault current they will switch on the maximum fault current grid and other one they will put minimum fault current and they will switch on based on the configurations. There is another possibility as well. You can go with the base revision option also, right? So means what to say, if we go with the means what to say, what I have done like means what to say, I have means played slightly with respect to not with the modeling two different grids, one with the maximum and other one is with the minimum, and putting the configuration tool with the opening and the closing breaker. What I have done, I have used means what to say base and other means what to say revision, where I am trying to means what to say change the fault current with respect to the maximum and minimum fault current. So from here you can understand the maximum fault current is about 37 kiloamps and the minimum fault current is about 11.2 kiloamps, and that's with respect to the three phase fault current. And with respect to the single line to ground fault current, which is pretty clear, like 3.2 kiloamps is given as the maximum single line to ground fault current, and 0.72 kiloamps, that is 720 amps, is given as a single line to ground fault current, which is a minimum value. Yes, thank you Kumaran and Muthuvel for answering that question. Like this is a resistance grounded systems. Yes, it's a resistance grounded system. How we have identified, there is a huge difference between three phase fault current and single line to ground fault current. So in that case it is essential to understand what is the resistance value also, because NGR plays a crucial role. So means NGR is the reason behind the fault current came down drastically, right? So means using the same X by R ratio, like means what many people, even though if they go with the resistance of the systems, they will use same X by R ratio. That's not really right. So means what say, when it is a resistance at the system, you need to get the actual NGR rating, and probably means what say you have to work out the means what say X by R ratio. X by R ratio should not be selected same as a three phase fault current and single line to ground fault current if the system is a resistance at the systems. Am I making it clear? If the system is resistance at the system, X by R ratio for both three phase and single phase is not same, because resistance at the system, the zero sequence only the resistance will be get added. So here I means what's it, the R value will be much higher. So means X by R ratio of three phase and single phase faults should not be considered as the same value if the system is resistance at the systems. Am I making a sense? Am I making it clear? Yes. If it is clear, probably you can type out clear in the chat box so that I can understand. Alright, good. So probably means how to find out this X by R ratio then? It's probably, I mean, so what say, you have to ask what is the NGR rating, that resistance value which you know, and probably means what say from there with the positive and negative sequence you will be able to arrive what's the zero sequence, right? So probably means what say zero sequence resistance will be much higher, or at least means what say from the NGR value you will be able to directly at least find out what's the zero sequence resistance, this percentage R which you will be able to find out. If you enter this, then probably means automatically you can back calculate it. You can back calculate this. So means what say this is a common mistake what we generally make, that's the real reason why I'm saying. So with that all probably means what say I'm coming back to this and leaving some questions which is unanswered. Probably for this please go back to some power system protection books, how means the fault current change with respect to this location of the fault, and this cannot be simulated in ETAP. That's a problem actually. Means what say if there is a fault within the winding of the transformer, that cannot be simulated using ETAP. So you have to look at some other simulation software. You have to look at some other simulation softwares and create a fault probably means what say with the different locations, and you need to work out means what's the fault current on both the HV side and LV side, and you have to come up. Probably means refer some protection books. We will discuss more on the next week. If that's fair, yeah, please. I mean, what say type out fair in the chat box. Yeah, there are some questions. Mohan Kumar, is it that need to calculate the zero sequence impedance? Yes, probably means that's what probably means what say what I'm trying to say. This X by R ratio will be different for three phase fault current and single line to ground fault current, because the neutral grounding resistor will come into picture only for a single line to ground fault current, not for a really three phase fault current. So means you need to find out percentage R directly from an NGR, because that is predominant impedance of all comparisons. So you can make that and you can back calculate this X by R ratio for a single line to ground fault current. That's an ideal way to do it. Yes, that's what how to calculate Muthuvel Ganesh. I guess probably you might be aware, like NGR, the resistance value might be given like 8 ohms, 10 ohms, whatever may be the resistance value that you know R. So means what say then R in per unit given by R actual divided by R base. You need to know how to find out the R base. R base is kV square by MVA, and you know R base, R actual by R base will give you means R in per unit. Then you can find out the R percentage. That's an easy way to do that. Yes, Kasim, I guess you have asked like a question, a message is retracted. I couldn't really find out. And if you have any answers, even if it is silly, no worries. I mean, everybody is beginners and learners. You can post the questions in the chat box, which I'm happy to take the questions. Not a worry at all, right? You can post. Yeah. What we have to do if we don't have X by R ratio, how can we assume? I guess probably means previous AskSelva 006 we have talked about this costing, like means how to take this value. You can very well refer that. So we have talked also like X by R is 10, that is IEC 60909, X by R 14 or 17 depends on 50 Hz system and 60 Hz system, that is depends upon IEC 62271. But we have also given like we need to ask upstream transformer, and from there we can get the actual X by R ratio that we have already discussed. Please go back to AskSelva 006, you will get the answer. And if not, probably post that question in means the Google form link where you need to register that questions for this AskSelva. We will I mean what say take it up, or probably at least we will give you means or comment it. We will give you the right link and what's the right time which we have dealt with. I think that's fair enough, Kasim. Yeah. All right. So I guess probably means what say I'm really stopping at this place. Thank you, Sreekant, for putting up quite a lot of efforts and coming up with some detailed write-up which you have given. So as I told, like this question is not really over. I have given something like means you have to work out with some custom protection books and probably means go depth beyond ETAP to create a fault at a different locations and find out the fault current. Try this for both HV side, LV side, delta star grounded, solid earth system, resistance earth system, all. Then means what say we will discuss more on the next week. Kumaran, is it necessary to calculate the zero sequence impedance when you are limiting the fault current to a particular value so that you can put so much impedance to the LG path? I'm not really getting a question. Let me read it again. It is necessary to calculate zero sequence impedance when you are limiting the fault current to a particular value so that, okay, I think that could be an answer for somebody. Yeah. If I am right, Kumaran, what he has put, like it is necessary to calculate the zero sequence impedance when you are limiting the fault current to a particular value so that you can put so much impedance on the LG path. Yes, that might be the answer to the previous question what I have asked. Thank you, Kumaran. Okay, why R plus protection has to be considered only for incomers, not for the outgoing feeders? That's a question from Charinath. So answer is quite simple. So we need to understand why do we need to do R plus. R plus is really needed when you are doing a maintenance on the switch gear in a live. Like let me take this switch gear. The switch gear I have not really modeled a breaker yet, but if you put a breakers also, right? Fine. So if you want to take out any one of this means panel for a maintenance, keeping others live, that's basically a live maintenance, right? So in that case, probably means what say you need to look at what is the appropriate personal protective equipments which we need to wear, right? It is needed for a live maintenance, or probably means you are taking some live readings from the switch gears standing in front of this switch gears physically, right? So R plus boundary restricted for means boundary, all these things which you will find out, and you will also recommend the PPE, personal protective equipments, etc. So having said that, means what to say, why we are not really doing for an outgoing feeders, why we are basically doing only for an incomers. So means if there is a fault in the switch gear, that will be dissipated as a heat, that will be an arc, etc, etc. If there is a fault in the outgoing feeder somewhere here, that's not really going to create any issues for the switch gear. So here I have not really given any outgoing models which you can model. You can probably model some outgoing feeders, cables and other stuffs. That's pretty possible, right? Yeah, I think that's some time lag when I'm changing this base configurations. All right. So what I'm trying to say example, if I'm putting another feeder with a cable, so for transformers and motors, I have not really modeled the cable, that's fine. So if there is a fault in the cable somewhere in the remote place, or some other place, then probably means only the fault current which is flowing through the switch gear. For that, the switch gear is capable of withstanding 40 kiloamps or 31.5 kiloamps for 1 second or 3 seconds and so much. So means what say that's not really about an arc on the switch gear. Arc flash, when we look at, there is an arc flash in this particular switch gear. That's where means what say you have to decide means what's the personal protective equipment which the engineer who is standing in front of the panel or doing the live maintenance has to wear. That's the question. So then probably if you look at means what say all these outgoing feeders will be protecting the downstream equipments, not really the switch gear. Am I right? So means if there is a fault in the switch gear, probably means that this is the only relay, that's an incomer is the only relay which has to isolate the fault, not really the outgoing feeders. If there is a fault in the outgoing feeder, then this relay trips up and picks up. But if there is a fault here, means what say the downstream equipments nothing to do with this incident energy. So means if we are working in, and probably if there is an arc, this arc energy or the incident energy is decided by two factors: what's the current which is flowing and what's the time taken by the breaker to open. So that means what's the I square into T, that becomes reflected as an energy, incident energy. Having said that, so means I is limited by the short circuit studies, that's decided or limited by the upstream impedance, that is I equal to V by Z, the source impedance, and T that decided by this fault clearing time of the relay. That's a real reason why means what say we are basically considering the incomer protection settings for means what say identifying the incident energy of the switch gear, not really the outgoing. Means outgoing relays will not have any impact. Outgoing relays will not have any impact if there is a fault here, because this is not going to really clear the fault. Even if this opens this breaker, still the fault is fed from this. I guess that's pretty clear, Charinath. If yes, I guess Charinath was there, so who can probably take it up that answer. Yeah. And one more interesting fact which I need to add, since you have asked this question. If we have more than one incomers, assume that this is coming from grid, and probably means you have a local cogeneration plant that generator is also connected to this bus. Then means what you need to really look at is like means what say you need to take the total fault current and assume that this relay clears the fault in 400 milliseconds, whereas this relay clears the fault in 600 milliseconds, then the highest time which you need to take. Refer IEEE 1584. If more than one sources, the last source which isolates a fault has to be treated as a fault clearing time. Right? I think that's clear. Vinod Krishnan, is X by R ratio same for single phase and three phase all-linear earth systems? Answer is not really again same. X by R ratio of three phase fault and single line to ground fault could be different. If you take a transmission line or a cables, the zero sequence is much higher than the positive sequence, approximately 2.5 times to 3 times. Zero sequence is much higher. Zero sequence is much higher than positive sequence. Let me quickly means put up the answer for you, Vinod. Let me give some parameters. Yeah, just give me a second. I'm trying to work out the positive sequence, negative sequence, and zero sequence. Maybe putting up some transmission line configuration, and I'm just trying to showcase. Yep. Yeah, here we go. If you look at, means what say, there is a huge difference between positive sequence and zero sequence. Am I right? If you look at, approximately it is 2.5 times to 3 times. So obviously then X by R ratio for the positive sequence and zero sequence will not be same if there is a long transmission line. It's understood. So similarly, even if you take for the generator, sorry, actually I'm getting a call. All right. So means if there is a generator, then probably means what say you can refer the generator as well. You can refer the generator as well. So means if we go and typically look at the impedance, x3 double dash is not equal to x2, which is not equal to x0. So then again, x by r ratio not really same for the positive sequence and zero sequence. So that means x by r ratio will be different for positive sequence and negative sequence. It means heavily spelled out in a resistance grounded systems, but in a solidly grounded systems also x by r ratio is not same. X by r ratio is different. I guess that answered your question, Vinod. Yeah, Vinod, I have answered that question if you understood. So you can type out yes in the chat box. I can understand. And Kumaran, I guess probably this is pretty clear. Like what you have said is right. In absence of X by R ratio for a single line to ground fault in a solidly earthed systems, then there is no other go. You can assume that is equal to three phase, but that's also not really true when your substation is fed from a long transmission lines, long transmission lines. Yep. Thank you. Causing, I think, not determine that error is coming simple fact because you are not really coordinated your relays and the fault is not really cleared by the relays. So that might be the reason that FCT is not determined is coming. FCT is fault clearing time not determined. That will come only when you have not really coordinated the relays properly. So means what say, if you have set the relays and probably means what to say, if you are correctly assigned with the circuit breaker, then that definitely that error will not come. So let me quickly answer that question also in the org flash. Okay, I think I have not really created a fault. Let me create fault at this bus and I will show you. Right. Yes, this is an error which you are getting, FCT not determined. This FCT not determined, simple fact because that fault is not really clear, right? So why here not fault is not clear? Because the relay is not really, I mean what say, isolating the fault. For that what I need to do? I need to configure this relay with the circuit breaker. I need to configure this relay with the circuit breaker, right? So probably means I have configured this relay with the circuit breaker. I have already given the settings. Now means what say that FCT not determined error will not come. Yeah, you can understand means what say, if you want to display the fault clearing time, you can display the fault clearing time, right? Yes. All right. So hope this is clear. That answered your question, causing. Yep. Thank you so much, Visak. Little fuse is one of the flash relays. Okay. Right. So means there are many ways of limiting the arc currents. So that probably means we will take it up separately. So that's not really going to discuss today. So I have few more questions of today. I will take up these questions. We have only 10 more minutes. Right. Motor protection relay curve between hot and cold, or it should be below both. So I guess most of you know the answer. Probably if you know the answer, you just type out. So his question is like whether motor protection relay curve has to be provided between hot and cold withstand capability or below both hot and cold. So all right. So I mean, what say I have just taken up small capacity motor like 800 kilowatt motor for this, and I have coordinated with this. So let me probably means take out this relay, and I'll go for a relay coordination to answer that question, Charinath. Yes, here we go for a relay. Yes. So means what say this is an ideal way of coordinating it. That means your relay curve or relay characteristics has to be above your starting characteristics at 100% voltage or 90% voltage or 80% voltage, 110% voltage, etc. But it has to be well below of motor hot and cold. If you are probably means what say placing this relay between hot and cold, then probably that means you are really missing out means the protection of the equipment. So it has to be below both. So the ideal coordination is not this is what your question, whether to place here between hot and cold, or means what say means below both. Answer is ideally means what say it's below both, right? Yeah, I think I have to probably reduce this. Yeah. So ideally, it should be below both hot and cold withstand, and it should be as close as possible to starting characteristics. It has to be as close as possible to starting characteristics, right? And your next question, which I have not really put up in the slide, like if we place this between hot and cold withstand, is it allows more number of startings? Answer is I mean, so to say, maybe it may allow, but that is extremely danger for this motor starting. Extremely means what say danger for the motor starting, and probably means what to say if we are really putting this IDMT curve, this is more than sufficient. Even means the hot or this one comes with respect to the how many starts which you are doing, that's not really going to be affected by this means what to say IDMT characteristics. So IDMT characteristics has to be means what to say much below this both cold and hot, and by means of increasing this above this hot doesn't allow you more number of starts. Nowadays means was a motor starting protection is completely separate from this IDMT protection. Yes, Venkat. So means what to say? We need to maintain this IDMT or the 51 protection above this motor starting and below the hot withstand. That's perfectly all right. Yes, or below both is the answer. That means below both the hot and cold characteristics. And even if you do not have a cold characteristics, that is fine with respect to means protection coordination. If you have only hot, that's also sufficient. I guess that answered the question of Charinath. If yes, you can probably answer it. Why it should be as close as to starting characteristics? That probably means for say for a much better coordination. So I can probably means for say keep the relay here at this place. Yeah, I think probably I am facing little struggle and selecting it. My mouse is not really working. Okay, all right. So means what say either I can move it as close as possible like this, or I can move it as close as possible to this. So means what say if I am moving it as close as possible, probably means what say this area is also protected. This area also is protected. Whereas if I am moving as close as possible, then probably means what say this area is not really protected, right? So anyway, we have assured that means what say the full load current is some amps, and the starting current is 6 times or 7.2 times. Even we are providing above 7.2 times only, so then probably means what say that current is no longer going to come. If it comes, then probably that's an abnormality, so for which you can protect the motor. That's most important thing. So that's the reason why means what say we just need to ensure that means what say this is as close as possible. Only thing what we need to ensure is like it should not mal operate during starting. That's the only thing which we need to verify. Kasim means what say absolutely there is no time discrimination which we need to maintain between this starting characteristics and this relay pickup current. Means what say it is not like a discrimination which we need to maintain. Even if it is like means what say 100 milliseconds, that's probably means what say more than sufficient. But only thing means you need to ensure that you are plotting all the characteristics, that is at 100% voltage and it is minimum possible voltage and maximum possible voltage. All this stuffs you have to plot, and probably means what say though it looks like there is a small gap, but you can understand there is about 2.25 seconds. That's a huge gap. I think Qasim, that has to answer your question. Okay, there is another question. If the calculated breaking current is 17 kiloamps, then the CB's current must be 20 kiloamps or 25 or 31.5. Is there any standard criteria? So there is no standard criteria. I couldn't read out your name, dear, but I mean, so say anything above 17 is fine, right? Means you have to take. I think this is a question which we have already addressed. One is the braking capability, second one is the making capability, and other one is the DC braking capability. You have to probably means what say validate that. All right. Fine. All right, Kasim, I'm not sure what you're talking about below the curve. I mean, what say, even if we means what say move it, probably means what say, there is a proper time discrimination is there. Like time is I means in seconds. Okay, but even this much is not really needed. And probably if you talk about this curve, there also the coordination is huge, because means what say you need to understand it's a logarithmic scale. It is not a normal scale, right? It may like physically looks like it's a small gap, but you can understand that time discrimination is 3.3 seconds. I'm not really sure what I have understood you or not, but that's if I have understood correctly means what say this is means what say logarithmic scale, probably means here even a large space will have only few milliseconds, but probably even a few space like a small space have time discrimination in seconds. So you need to assume always that that's the logarithmic scale, right? If motor is protected with 51, thermal overload protection can be setted or need to not be. If the motor is protected with 51, no, my dear Muthuvel, means we need to provide a thermal overload protection also. 51 really doesn't protect motor for a thermal overload, right? This is applicable for medium voltage also. You need a dedicated thermal overload protection relay, which is 49. That 49 is mandatory, right? Let me go to the last question. Sorry. I think I have some other programs, that the reason why I'm getting keep calls. Anyway, I'll finish it up. What's the significance of maximum and minimum ground fault current and relay coordination? This is a question. I thought of coming with a simulation. I will continue the simulation probably means for upcoming days also. So I have taken this for an easy understanding, like means you can take it. I have given the three-phase fault current of 37 kiloamps as a maximum fault current, assuming that means say four numbers of 30 MVA transformers are parallel upstream, and I have taken the minimum fault current of 11 kiloamps, that is means say when only one transformer is running, right? So that means there is a huge mismatch between the minimum fault current to the maximum fault current, which you can understand 37 kiloamps is the maximum fault current, whereas 11 kiloamps is the minimum fault current. And the single line to ground fault also, like only one transformer is connected, only one NGR, so it is about 800 amps with 0.9 C factor. I have worked out 720 amps, and where there is four transformers with 320 amps and 1.1 C factor, it is around 3.6 kiloamps, which I have worked out. In this case you can probably simulate. I have already made some graphs which you can try it on your own. I'm not sure what's the graph which we have made. I think it's in star 2. Right. So here you can understand there is something called the minimum fault current. You can look at this is the minimum fault current which I have plotted, and here it is the maximum fault current which I have plotted. If I have coordinated this for a minimum fault current, then my IDMT curve will be something like this. If I am not integrating, right? But probably means what say here means what say if you look at the discrimination, if you need to maintain means what say 200 milliseconds discrimination, this is for the minimum fault current, this line which you can understand, and for the maximum fault current that discrimination is missing, which you can easily understand. So that's the real reason why means I'm keep asking to means coordinate this for this you can, yep, I can put this somewhere, yeah, I can adjust this, yep. So here the discrimination is there, but probably means what say this is coming down. So means what I mean to say, you need to coordinate for the maximum fault current, that is 37 kilometers or whatever the fault current, not really for this 11 kilometers. So that means you need to increase the time dial setting to ensure that the coordination is there. Coordination is there even for the maximum fault current. So that's the answer. All right. So, I think Qasim, thanks Balraman for putting up this. Qasim is talking about, asymmetrical factor. Yes, we will take it as a separate class, and we will talk more than that. And means to get that question answered, please put it in the Google Forms. That's available in our LinkedIn page. You can put it. I could understand. This is the factor which you are talking about, asymmetrical factor, that basically decides or dictates the instantaneous setting, not really 51 setting. That's not really going to dictate anything on 51. That's dictating only on the setting of 50. That is an instantaneous setting, right? Like I can just go to the graph and I can just show you there. Yes. So this is fine. So I mean, so say anyway, this motor has to trip instantaneously, but the fault current is not really, means motor starting current is not really going beyond this. So above that, it can trip instantaneously. So here there is no time discrimination which is really needed. But means with the asymmetrical factor of 1.6 or 2 or 1, how to coordinate that we will take it in a separate class. Thank you, Qasim and Balraman. Vishok, is it same for an LV? Yes, means what say you can understand, like even with an MCCV, you may be having a bimetallic overload, thermal overload relay for low voltage motors also. It depends on the customer how much he is willing to spend. All right, thank you then. So probably means we have covered an hour. So I'm happy to meet you again on next Sunday at 10 a.m. Right? Thanks for coordinating. And probably means if you want to register for our advanced course on this industrial power system analysis, that most likely year-end holiday for everybody. That starts on December 27th, and that's a 5 days class plus 2 hours session on every month for the entire year of 2021, that me along with the Dijo is going to handle the sessions. And probably that syllabus what I have shown, that will be out in our LinkedIn page very soon. So this is the concepts along with quite a lot of case studies which we are going to take it up. So if you are really interested, please register by means of looking at our LinkedIn page. Thank you so much for joining. Have a nice day. We will meet again at next Sunday at 10 a.m. Thank you so much.